Hello everyone. So welcome to our lecture number 5. So we will continue our application of dimensional analysis in this lecture also. So here is one question about the application of dimensional analysis. Okay, let's start the question. In this SI system, the magnitude of pressure is 50 Newton per meter square. So in another system where the fundamental quantities are kilogram, meter and minute, find the magnitude of pressure. That means we have to find, or we have to convert 15 Newton per meter square into a new system of unit. Yes. So how to solve this? So first we have to write about first system, and here is our second system. Yes, the unit is mentioned Newton per meter square. So unit is mentioned Newton per meter square. We can find the dimension. Newton is the unit of force, so its dimension is 1 minus 2, and meter square, its dimension is L2. So the answer is M1 L minus 1 T minus 2. Yes, so 1 minus 1 minus 2 is the dimension. So in the middle part you have to write 1 minus 1 minus 2 is the dimension of this given quantity. So A value will be 1, B value is minus 1, and C value is minus 2. So in first system N1 is mentioned 50, so N2 is equals to question mark. So as the first system is in SI system and second system is new system. So in SI the M1 value is 1 kg, L1 value is 1 meter, and T1 value is 1 second. And in new system it is mentioned M2 is equals to 1 kilogram, and L2 is equals to 1 meter, and T2 is equals to 1 minute. That means 60 seconds. So by using the formula, working formula is N2 is equals to N1 into M1 by M2 power A, then L1 by L2 power B, and T1 by T2 power C. So this is equals to 50 into M1 value 1 kg by 1 kg power A value is 1, then 1 meter by 1 meter also, L2 value is 1 meter power B, that is minus 1. The next one is 1 by 1 second by 60 seconds, 1 second by 60 seconds power minus 2. So it will be 1 power 1, then 1 power minus 1, 1 by 60 to the power minus 2. So 50 into 1 by 60 to the power minus 2 is 60 square. So this is equals to 60 into 60. So we can say 1840, that is 18 into 10 to the power 4. Yes, so thus we get the answer 50 Newton per meter square is equals to 18 into 10 to the power 4, 18 into 10 to the power 4 in new system. Or we can write this is equals to 1.8 into 10 to the power 5 in new system. This is our answer. So next is come to our second application. Second application of dimensional analysis. Yes, so what is about this application? Now see here we will discuss to check the correctness of, or to check the dimensional consistency, to check the dimensional consistency of given physical relation, of given equation. This is the aim of this second application. Okay, for example, let us consider mechanical energy E is equals to, we know mechanical energy that is capital E is equals to half mv square plus mgh. Okay, so check it. So check it means as per dimensional analysis. That means we have to find dimensional of LHS and dimension of RHS. After that we have to compare the both side of dimension of both sides. Okay, so next is dimension of LHS. In LHS energy is there, so energy dimension is 1 2 minus 2. Yes, and then dimension of RHS, and in RHS two terms are there, half mv square dimension plus mgh dimension of mgh. This is equals to half has no dimension, then mass dimension is m1, then v square, v dimension is l1 t minus 1, then power 2 plus mgh, and in mgh mass dimension is m1, then g is acceleration due to gravity l1 t minus 2, then h is l1. So this will be, if we will solve this part, if we will solve this shaded portion, this is equals to m1 l2 t minus 2, and next solve this pink color shaded portion. So this will be equal to plus m1 l2 t minus 2. Okay, if we will add same dimension, then the answer remains same, that is equals to m1 l2 t minus 2. So from this we came to know that thus LHS dimension, or we can say, or we can write here, thus dimension of LHS is equals to dimension of RHS. Proved. So in this way we can check the consistency of dimensional consistency in a given equation. Okay, so always remember one note point. This is one important point actually. In note point what we will discuss, listen it properly. Every correct mathematical formula, will always follow the principle of dimensional homogeneity. This is true, but the reverse is not true, or inverse is not true, but the inverse is not true. Yes, let us consider one example. We know time period of oscillation of simple pendulum, that is t equal to 2 pi root over L by G. Let us think, let us assume let time period of oscillation is t is equals to 4 pi root over L by G. So dimension of LHS is equal to dimension of time period, that is m0 L0 t1. Then dimension of RHS, that is equal to 4 pi, dimension that is a constant. So 4 pi is a constant has no dimension. Next, that is we can write it as 4 pi into L power 1 by 2 divided by G power 1 by 2. Yes, or in simple way we can say it is equal to L by G whole power 1 by 2. So as per the dimension of L is L1 divided by G dimension is, it is one acceleration, we can write L1 t minus 2 1 by 2. So this is equals to 4 pi has no dimension. So in the bracket, inside the bracket, if you will solve, it is equals to t to the power 2 whole power 1 by 2, that is t, dimension of t. So thus LHS dimension is equals to RHS dimension. Yes, but the real relation is, this is not the correct relation, but the real relation is T is equal to 2 pi root over L by G. So we can think every correct mathematical formula will always follow principle of dimensional homogeneity, but the inverse is not true. Okay, let's solve some numericals related to dimensional chapter. Yes, this is under the third application actually, to find the dimension of unknown quantity. Here we can say third application, that is to find dimension of unknown physical quantity. Yes. So according to the question, the following equation gives a relation between the mass m1 kept on a surface of area A and the pressure P exerted on this area is P is equals to m1 plus m2 by A whole into x. Okay. So as per the formula, P is equals to m1 plus m2 into x divided by A. So here P is pressure and m1 is your mass and A is area. Okay. So find the dimension of quantity x and m2. So we have to find the dimension of x we have to find, and dimension of m2 we have to find. Yes. So in this expression m1 plus m2 is given. That means if we will think about this expression m1 plus m2, yes, that means two quantities can be added if they have same dimension. That means m1 dimension is equals to m2 dimension. That is equals to m1 is mass, that is equals to m1 L0 T0. Yes. Then we have to find the dimension of x. So from this formula, we can say x is equals to pressure into area divided by m1 plus m2. So dimension of x is equals to dimension of pressure into dimension of area divided by m1 plus m2 dimension. So dimension of pressure is our m1 minus 1 minus 2. So 1 minus 1 minus 2, and your area is L2. Area is L2 divided by m1 plus m2, that is your m1. Yes. So you will get m power 0, L power 1, L power minus 1 plus 2, that is 1, and T power minus 2. T power minus 2. This is your answer.